Okay, last topic is solving radical equations. Okay, actually very simple stuff. The steps to solving radical equations, the ugly part of that equation, for example, in number 4, is the radical, right? What's our goal here? Our goal is always when we're solving an equation to isolate the variable. Well, how am I going to isolate that variable if it's inside a radical? Well, the answer is I've got to undo the radical, right? So here's our process then. We're going to isolate the radical on one side of the equation, and then we're going to raise both sides. I treat both sides equally, right, in an equation. So I'll raise both sides to whatever power I need to undo the radical. Now, what power is that going to be? Well, the power is given to us by the index of the radical. Okay, so if this is a square root, what's the number that's sitting on the radical? 2. So what power am I going to raise both sides to? 2. Yeah, I'm just going to square both sides to undo the square root, right? Okay, so then once I undo the square root, I'm going to get a simple equation, right? Old hat stuff. You guys have done it thousands of times. We solve that equation, and this is a key though. This is one where sometimes people, checking your answer is, always sort of pseudo optional, but not in this case. Extraneous. Extraneous means false. Okay, so that's just a synonym for false. Okay, when you're solving radical equations, checking the solutions isn't just a good idea, it's essential, because when you take both sides of an equation to a power, you can always introduce these extraneous or false solutions. So you got to check them all and see which ones are extraneous and which ones are actual solutions. Okay, see what I'm saying? We'll look at some examples. So number 4 then, what's my first step? Subtract 10. I've got to isolate that radical, right? So first step is subtract 10. And if I do that, I'm going to get square root of 6w minus 5 equals negative 7. Okay, now what am I going to do? Okay, go back up a little bit. All right, let's look at it. Yeah, how do I get rid of the square root? Square both sides. Okay, so I'm going to change colors here, because when I square both sides, that's the step where we could introduce extraneous solutions, right? So we'll square both sides. What do I get on the left side? Yeah, right, because squaring it just undoes the radical. So I get 6w minus 5 equals 49. Seriously, it might be. I mean, this is going to be a big step back from the rational, solving rational equations like we did last time, right? I mean, those were a little tougher. Okay, so last 2 steps to isolate w. Add 5, divide by 6. Okay, so then we get 6w equals, what are we getting here? We're adding 5, so I get 54, divide by 6, and I get w equals 9. Are we done? What do we got to do? We got to check it. So now, when we check it, do we have to go back to the original equation? We always can. We just need to go back to an equation prior to squaring it, right? So why don't we just go back and check that one right there? How about? Where it's just a little bit more simplified, right? Okay, so if I plug the stuff in there, what am I going to get? Well, it looks like I'm going to get the square root of 6 times 9 minus 5. That's 49, right? I'm going to get the square root of 49 equals negative 7. Is that true? No, that is not true. What's the square root of 49? 7. That's not true So that means I have to cancel that solution. And what's the answer? No solution. Okay, now can anybody tell me where maybe we could have predicted this earlier?
From the very beginning, honestly.
What do you mean by the very beginning?
I mean, like,
when you subtract the 10, you get a negative on the other side. You get a negative.
There you go. Exactly. There's where we could have predicted this right there. Look at that.
I'll be honest, you told to say that.
Did he?
He knew the answer.
Yeah. Good. Yeah, good. Well, I knew that. Right. So can the output of a square root ever be negative? No, it can't be, right? What's the smallest the output of a square root can be? No. 0. What's the square root of 0? 0. And then the next smallest to be the square root of 1 is 1, right? If we're talking integers. There's no way I can get a negative out of this. So this could have predicted right there the fact that we had a square root equal to a negative number. That would have predicted that we were going to have some problems. Okay? Give me 1 to 5 on that first example. How we doing? Okay, good. All right. I always like to see that. That's good stuff. Okay, let's try another one. How about this guy right here? What's that? Same thing. Yeah, what looks odd about this? The fraction. Okay, but what does a 1/3 power mean? What kind of root? Cube root. There you go, right? Because remember, if we have a fractional exponent, the denominator tells us the index of the radical. So this is the very same thing as the cube root of 7p minus 1. Same thing, right? Now, write it as a cube root? I mean, not really. We can if we want to, but you don't have to. Yes? Okay, yeah, we'll talk about that. Good question. Good question. So how about if let's just rewrite this as a cube root, even though we don't really have to do this, right? But we could rewrite this as a cube root of 7p minus 1 plus 11 equals 7. Okay, so first step would be to subtract 11. And we end up with the cube root of 7p minus 1 equals negative 4.
It's not a no solution because of the cube root.
Aha, because it's an odd root, right? It's only the even roots that can't give us negative outputs. What's the cube root of negative 8? Negative 2, right? Odd roots can do that. Odd roots can give us negative outputs. So in this case, this is okay. Let's make a little note about that. Okay? Make sense? So we're okay. So now what do we do here? We isolated the radical. Now what? Cube both sides. Okay, cube both sides. So if we do that, if we cube both sides, what's that going to give us? Okay, everybody agree? Left side, we're getting the cubing undoes the cube root. So that just gives us 7p minus 1. What's negative 4 cubed? Negative 64. And now we just solve it. Last two steps? Plus 1 divided by 7. So we get 7p equals negative 63. So p equals negative 9. Okay. We got to check for extraneous solutions. Okay. So if we plug that back into, let's go back to this one right here. Okay. So if we plug back into there, what's that going to give us? Okay, then we get the cube root of 7 times negative 9. That's negative 63 minus 1, negative 64. equals -4. True or false? True. So that is a solution. Okay. Now the books don't ever say this, but I want to ask you something. I can save you a little time on this. Do you think I'm ever going to have a problem with extraneous solutions if I take an odd root and if I have to take each side to an odd power? You're not going to. It's only when you take both sides to an even power. And the math behind that, if you're interested, the math behind that has to do with the symmetry of the functions, right? If you've got, this is extra stuff. I mean, this is kind of high level stuff, but I'm just going to show you something here real quick. Might be interested. If I look at something like a cube root looks like this. A square root looks like this, right? Now, the problem with the square root function is the square root function comes from that equation, solving for x. And what happens there is that violates the vertical line test, and so that's the problem. The problem there has to do with the symmetry of the root functions, okay? I mean, just if you're interested. The cube root function is 1-to-1, meaning there's for every value of x, there's exactly one value of y for both the function and its inverse. But I digress. Let's not worry about that stuff for now. If you're interested, that's why. But okay, so how about one like this? Okay, I mean so ultimately this is going to be a little different, isn't it, this time? Because if we follow our instructions, it says isolate the radical. Well, how are you going to isolate the radical when there's two radicals? That doesn't make sense. So we got to change our instructions a little bit here to isolate a radical, whichever one's the most convenient to isolate. Which one's the most convenient to isolate here, probably? Yeah, because we could divide both sides by 4 and then we don't have a fraction. Wouldn't that be better? Everybody agree? So if we divide each side through by 4, those guys cancel, and I end up with the square root of 3q plus 15 equals 3 times the square root of q. Good? Okay, now what? Now what would I do? Square both sides. Okay, now what's a little bit different about this is I've only got the radical isolated on one side, right? But it's not going to be a big deal. Let's see what happens. If I square both sides, what's that going to give me on the left side? 3q plus 15, no big deal, right? Okay, on the right side, let's think about some stuff we already know and apply some concepts we already know. This looks a little scarier because we've got square roots in there. But if I asked you guys to do this, 2x quantity squared, you could all tell me that the answer is what? What is it, Andre? 4x squared, right? What Andre do that I'm probably trying to emphasize here? Squared both. Yeah, he squared both, right? He squared the 2 and he squared the x. So we've got to do the same thing here. We've got to square the 3 and square the square root of q. So what am I going to get? 9q. Everybody agree with that? See that? Okay, so I get 9q. And now it's easy, right? Now it's easy. So now I'm just going to push the q probably to the right side. So I get a positive number of q's. I get 15 equals 6q. So q equals 15 over 6, which is 5/2. Okay. Now that's a little bit inconvenient to plug back in, isn't it? because we'd plug that probably into here, right? We got to go back before we squared both sides. If I plug it in there, that's a little inconvenient. Let's remind ourselves about how we could even use like Desmos Scientific on this to help us out. Okay, so if we want to evaluate functions, I mean, if we're just checking functions, all we're doing is evaluating each side of the function. Come on, there we go. Okay, so what are we doing then? I'm just going to plug 5/2 into the left side. You guys remember this? This was a great trick I showed you earlier. What did we do there? Do you remember? Oh, there we go. Okay, so we're going to define a function for the left side. So we'll call it f of, and we can even call it f of q this time if we want to. F of q equals square root of 3q plus 15. And then what do I do with that f of q? I said f of q equal to 5/2. F of 5/2, right? Because I want to plug, what am I trying to do? I'm trying to plug 5/2 in for q. So f of 5/2 gives me that crazy decimal, okay? Now notice I don't have the option of turning that into a fraction because it's irrational. It's a square root, okay? So that's not surprising. Now what do I do? What else? So that's the value of the left side when I plug it in. But I got to call it something else. I got to call it like g of q, okay? So g of q equals the right side, which is 3 square root of q. And then I just do g of 5/2. I get the same thing, okay? So what's that tell me? It's good. It worked. Okay, so let's see. Just for our notes. Yeah. Where am I going to put that for our notes? I just got to make it a little smaller. There we go. So those both checked out, didn't they? So that solution worked. Okay, give me 1 to 5. How are we doing? Okay, good, good. Okay. All right, so what about one like that? Got variables on both sides, but that's not a big deal. I just follow my same pattern. What would I do first? Okay, good. Subtract 7a, because I got to isolate that radical, don't I? So if I subtract 7a from both sides, I'm going to get square root of 12 minus a equals a. Now what? Yeah, square both sides, right? Because I got to undo the square root. So if I square both sides, I'm going to get what on the left side? On the right side? Okay. Now, I got an equation that looks like I've been doing those since Unit 4. That's no big deal. How would I solve that? Yeah, I got to set it all equal to 0, right? Because everybody see, I'm going to get a quadratic equation. I'm going to have a squareds and a's in number. That looks like a quadratic, right? So we're going to push everything over to the right side, and I get a squared, what? Plus a minus 12 is all equal to 0. Yeah, and let's just put the 0 on the right side just to make it look normal, okay? Now I've got a quadratic equation in standard form There's no reason to ever panic here because worst case scenario, how could I solve this? Quadratic formula will work every time, unfailingly, no, absolute guarantee. But is there an easier way here? I could find magic numbers and factor this thing. It's a lot quicker, isn't it? So I could factor the left side, and the magic numbers that would go with A would be +4 and -3, right? Okay. So then what are my solutions? I'm gonna have to check them, but what are at least my preliminary solutions? -4. Okay, that's the zero by the zero product property, right? That's the solution of that guy, or A equals 3. And now I've just got to check those guys, right? So I'm going to go back and plug those into here and just see if they work. Well, I don't have to do the original. I could. I don't have to do the original one. Why is this one okay, but this one's not? Before I square it. As long as I go back to before I square it, I'm okay. Okay, so let's check. Let's check 4. Or -4 was 1, right? -4 was 1. Okay, so if we check -4, we're going to get square root of 12 minus -4. What's that? It's +4. So I'm going to get 16. Square root of 16 equals A, which is -4. True or false? False. Okay, that one is not true. So that's telling us that solution was extraneous. Cancel that one. Let's check the solution A equals 3. And it might be extraneous too. That happens. So let's check it and see. We get square root of 12 minus A, which is 3, gives us what? Square root of 9 equals A, which is 3. Is that true? That is true. So this guy is good. Okay, makes sense? Okay. I'll give you an option here. The assignment's up. Do you guys want to do one of these on the board, or would you rather just jump into your assignment? I don't care. Whatever works better for you. You guys would rather jump into the assignment and work on. Okay, then I got one more to do that's a little bit different. So hang on just for a sec. But here's where I would put in a practice one if you thought you wanted to do one on the board. I'm okay with that totally. But what I want you to do is this. Here's before I forget. I'm gonna tell you this. So when I'm done here, you're gonna have a decent amount of work time. Jump into the 7.5. What is this? This is what? Yeah, 7.5, right? We're unit 7.5 assignment, the last one, and do some problems. Do like 3 or 4 problems, just to make sure that that's the fee I'm charging for not. You got to go in and do a few of those. It's your homework anyway. You got to do it. So do a few of those. Once you've done a few and you feel like okay, I got this, then you can either keep going or go back and work on something else. But you got to at least try a few of them to make sure. Okay. All right. So last one. This is kind of a tricky one, kind of a bonus type question. What could I do here? I've already got a radical isolated, so I would just square both sides, wouldn't I? Okay. So what's going to happen here? You see, this is going to be a little bit weird though. Right? When I square both sides, left side's easy. Just getting x plus 9. Right side's a little bit tricky because what I'm really having to do here is square out that binomial. Now, hopefully you're using the pattern, right? Hopefully you're using the pattern a plus b quantity squared, this pattern. It makes it way quicker. A plus b squared equals a squared plus 2ab plus b squared. That's what we do so much of this that's just worth memorizing. It saves you lots of time this year and next year. You could FOIL it out, but let's use this pattern. So if I apply this pattern then, what is the square root of x minus 1 squared? So what's my a in this case? Square root of x, right? So if I square that, I'm getting x, aren't I? Okay. 2ab, so I'm getting plus 2 times, what's a again? Square root of x, right? What's b? Negative 1. Okay, plus b, which is negative 1 squared, right? Because this first one was really just the square root of x squared. So now what's that give me? Well, I get x plus 2 times the square root of x times negative 1. Well, that's just minus 2 square roots of x, isn't it? Right? And then negative 1 squared is plus 1. So on the right side, I just get all that stuff. Okay, but what's the, what makes this one a little bit harder problem? There's still a square root. So what would I do?
You'd have to square it twice, right?
Yeah, I'm going to have to isolate that one and square again. But it will come to an end, right? We made progress here because now instead of having radicals on both sides of the equation, I've only got one radical left. So I have to just isolate that one and square both sides and then solve the equation to get my possible solutions, right? Okay, so we could subtract x from both sides. Now, conveniently, this works out well in this case because look, those x's cancel. If I subtract the 1 to the other side, I'm going to get 8 equals negative 2 times the square root of x. Next step? Not quite. Divide by negative 2, right? So I get square root of x equals negative 4. Now what? Now I square both sides, yeah. So if I square both of these, I'm going to get x equals 16. And then what would I have to do? Well, check it, right? So I'm going to go clear back up to my original equation and check that. Okay, so if I do that, if I plug 16 into my original equation, we're going to get square root of 16 plus 9 is square root of 25 equals square root of 16, which is 4, minus 1. Is that true or false? False. So that's telling me that's extraneous. So what's my answer? No solution. Okay, give me 1 to 5 on that one. Good? Okay, all right. Go to town. 7.5.